Welcome to solverfy.
Okay, so the idea here is how to show a system of linear equations and represent it as matrix form. So if we have a system of linear equations where you have like a11 times your first variable plus another constant times your second variable and so on until your last variable. So like if you had those three variables might be x, y, z as you would commonly see them. And then what it's equal to, right? And so these a and b are just some sort of constants. Okay, and then you get your next equation, and so on and so forth. Okay, and so the process here is then that we sort of break it up into a matrix for the constants attached to each variable, right? So we would get a11 and then a12 all the way to a1n. And depending on how many you have here, this can be a_n_n. Okay. And then next to that, okay, so this is our n by n matrix. Then we'll have our variable matrix, right? And this is, of course, an n by 1 matrix, but that means you can see that they can be multiplied, right? Because there's n elements in the row and then n in the column. So when you go through and you multiply, you'll get a11 times x1, a12 times x2, all the way to a1n times xn, right? And that gives us our first equation. And so then that's going to be equal to our b1 here. Okay. And that, of course, is also a n by 1 matrix, right? Because if we were to multiply these together, then we're going to get an n by 1 matrix, and that results from here. And so this is how you would represent our system of linear equations with a matrix, an x matrix, and a b matrix. Okay, so then part B has us looking at how to show that we can find the solution using our x matrix being equal to the inverse of our A matrix times B. And so we ended here, this would be represented as sort of A matrix times X matrix equals our B matrix, right? So we ended with this AX equals B. But if we were to multiply both sides by the inverse, okay, so we get multiplying both sides by the inverse, then the inverse times A, well, that's going to be equal to the identity, right? So that gives us the identity times X being equal to the inverse times B, but the identity times X is just equal to X. Okay, and so that's how we get that we can find X from the inverse times B.